And this is the January Building to Net Zero Community of Practice. Yeah, just a reminder, you heard the recording notice there, so this meeting will be recorded, and we'll be posting on our website in a few days. We're going to do a longer presentation style today, and then get into some questions after. And yeah, to open it up and um, everyone, yeah, we encourage cameras on. We encourage everyone to introduce themselves in the chat. And we've spoken a lot about net zero buildings in this community practice. And we're going to dive a little further into its meaning in the introduction here. Um, so there's net zero electricity, um, which is more about the electricity itself and not on the natural gas. It's electricity consumed by your building. It's also produced by a building usually using solar panels, and it doesn't include natural gas. Next, we have net zero energy. Is the energy consumed by the building is also produced by the building, usually using solar panels. So that does include producing more than enough solar power to offset some natural gas or other fuels used in the building. Next, we have net zero emissions or net zero carbon. And so that's where the building doesn't emit any emissions or offsets any emissions generated using offsets like planting trees or selling excess solar to the grid. And this is what we usually mean when we talk about a net zero building and what we're striving for in this community. Um, Going even further, you can have a real zero or a zero emissions building, which generates absolutely no emissions, not even related to the electricity used in the building. And that's you can either do that by being off the grid entirely, and using solar to generate your power, or connecting to an electricity grid that doesn't generate any emissions, which a few provinces are very close, but not quite there yet. And then you can go even further and get into net negative or climate positive, where the building actually reduces emissions over time using solar panels to produce all on-site electricity, as well as using other actions, climate positive actions like on-site tree planting or other GHG removal techniques on-site. But the common differentiator of all those is it only talks about operational emissions. And today we're going to get into more of that broader aspect of the embodied carbon or embodied emissions. And I'm really excited to introduce Ryan Zizzo, our speaker for today. Um, he's the founder and CEO at Mantle Climate, a Toronto-based climate change consultancy focused on climate-smart infrastructure and buildings. His team incorporates life cycle approaches to make projects future-proof and net zero carbon ready. He's worked directly and supported on the update on the Toronto Green Standard version 4, North America's first policy to limit embodied carbon on certain types of new building construction. And he's also contributed to the development of the Government of Canada standard on embodied carbon in construction, requiring low carbon concrete on large federal construction projects. Really pleased to have you, Ryan, and take it away.
Awesome. Thanks so much, Nathan. And yeah, great to be on the call and thanks for the invite, everyone. So let me just share my screen. Okay. So yeah, I've got about 40 slides to get through, and then we can have a bit of a discussion at the end. So um, hold on to your questions and we can have a good chat at the end. So yeah, thanks for the great introduction. One thing I also wanted to just point out so that folks know, on the second last bullet here, we are actually working on embedding embodied carbon. Sorry, I shouldn't have used the word embedding. Putting embodied carbon into the 2030 National Building Code. So that is coming. The plan is that this will be part of the national code in 2030, and then hopefully the provinces would adopt that. So my team at Mantle, we're 16 folks now, mostly in Toronto, have some folks in Alberta, BC, and Quebec as well. And we are all about finding benefits that are good for the climate and good for business and finding ways to partner with our clients to make that happen. Some of the clients we've worked with here, we've got others shown on our website, but we're all about the built environment, decarbonization, and more climate resilience in the built environment. My background, just to quickly say, is in structural engineering. I worked as a consultant in Toronto for 10 years doing group lead certifications, and then I moved to Finland for 3 years. And I tell people I saw the future when I went to Finland because they're so far ahead of us in sustainability and green buildings in the Nordics. And I came back to Canada 10 years ago now and founded my consultancy to work on what I think is of as the next level of sustainability. And I think embodied carbon is a big part of that. It's not really common right now, or it's becoming more common, but it's still there's still a lot of education that's needed, and management practices need to be scaled up. So that's what today's all about. So today I'm going to be giving a little bit of an intro to embodied carbon for folks that aren't super familiar with it. We'll go through a couple embodied carbon management opportunities. And then I'll talk about some of the policies that currently exist around this, specifically the Toronto Green Standard and some other Toronto policies and the federal standard on embodied carbon construction, which was introduced a few years ago by the feds. And then we'll have some time for discussion. So Nathan did a great job of describing embodied carbon versus operational carbon, but I always just like to start off with a picture like this to show, both of these are part of the total life cycle, what we would call whole life carbon of a building or a piece of infrastructure. Both pieces need to be managed to get to net zero. If we have net zero operations, fully renewable energy, but we're still making our concrete and our steel out of really emitting sources and shipping them using fossil fuels, then it's really not a net zero problem at the end of the day, right? So we really need to be looking at both of these pieces together, and we're going to be talking about that often overlooked and not so well understood by lots of folks currently, embodied carbon. This graph or this image is good because it just shows that there is a big portion of our global emissions that are due to these embodied carbon of construction materials, which most people don't realize. It's around 11% of global emissions is from the emissions associated with creating the materials that we build out of and transporting them. The other piece there you can see is the light orange is building operations. So that's around 30%. So when we take those together, the built environment sector is around 40% global emissions. So obviously a big part of what we need to change in the future to get to net zero. This image just shows the different life cycle stages from the ISO international standards on how we break out the life cycle stages of a building. And if you get more into life cycle assessment and embodied carbon management, you'll start seeing these alphanumeric codes, A1 to A5, B1 to B7, C and D. And I just wanted to kind of take a minute to show that's what each of these codes are related to a separate life cycle phase of the building. And there's different emissions associated with each of these phases. So you can see the product stage up front, A1 to A3. This is the extraction of the raw materials. This A2 is the transportation of those raw materials to a manufacturing facility. A3 is the manufacturing process itself. So you can think about each of those three phases have separate carbon emissions associated with them. Once the materials are manufactured, they get shipped to a construction site. That's A4. Once they're on the construction site, they get installed using diesel and other fuels on site. That's the A5 piece here, installation. And all of that together we call upfront embodied carbon. So that's all the embodied carbon that happens before a building is actually occupied. We then switch into the use phase, which is B, and you can see there's different aspects here of using materials, the maintenance of materials, repair of systems, replacement, refurbishment. All of these are things that happen over the 60 to 100-year lifespan of a building, and there's emissions associated with each of these phases as well. And you can think these things wouldn't show up on an energy bill, right? I kind of describe this as these are the things that don't show up on your energy bill, but they still are a carbon impact of the building. The things that do show up on your energy bill is this B6 and B7. This is where we call operational carbon. And then once the building is decommissioned, then we go into the C phase, which is the end of life. So deconstruction, demolition, transportation to final disposal facilities, waste processing, disposal. And then we also have something called D, which is kind of about the circularity aspect. If you were to reuse materials in another building, it gets captured in the D life cycle phase. But wanted to just spend a minute to actually go through those and just show the different life cycle phases. So again, operational carbon, this is the thing that we've really been doing a good job of managing and reducing over the course of my career, the past 20 years. And I'm sure everyone on this call is probably much more familiar with operational carbon than embodied carbon. That's pretty common. And how we manage operational carbon, how we manage operational carbon is when we're designing new buildings, we often ask for an energy model. So anyone on this call who's involved with procurement of new buildings, you probably ask your designers for an energy model. It represents or estimates and models the amount of energy that we would think. It's kind of part of par. It's kind of par for the course these days. The other pieces, the embodied carbon life cycle stages, those are all managed and modeled through something which we call a life cycle assessment or an LCA. So you can think of an LCA as to embodied carbon as an energy model is to operational carbon. So LCA or life cycle assessment, it's just a methodology. It's an approach that we use to quantify the life cycle to quantify the environmental impacts of all these different phases. And LCAs are increasingly being asked for as part of things like LEED certifications, zero carbon certifications, some leading organizations, and jurisdictions. We'll talk about Toronto and the feds later on. Those are the types of areas where LCAs are being requested. It's not currently a requirement across the board, but I think we are getting there. As I said in my intro, we're working on the 2030 building code to embed, again, I keep saying that, embed embodied carbon into the code. So I guess what I'm saying is we're moving. LCA is where is where energy modeling was at the start of my career, right? As I said, when I started my career, energy modeling was kind of novel, and now it's standard. I think that's where we're at with LCA currently, is that right now it's a little bit novel, only the leaders are doing it, but I think in 15 years, probably before that, it's going to be a standard part of building construction, because let's be honest, we need to reduce the carbon footprint of our construction, and that's what this is all about. So I like this slide because it kind of just shows why embodied carbon has becoming more and more urgently, or why it's becoming more there's a brighter light being shone on it. I guess it's getting more attention because buildings of the past looked like the top part of this graph, and this just represents cumulative emissions in the atmosphere from a building over the course of a, say, 60-year life cycle. When I started my career, when we made buildings, they were not very efficient, operationally speaking. They used a lot of energy. Energy was dirty. We had coal that we used to make our electricity, and when you added all that up, the amount of carbon from operating the building over 60 years vastly outweighed the amount of carbon from making the building from the embodied. But that's changed. Now, buildings that we build today look much more like the slide on the bottom, or the image on the bottom, where we've really done a good job of bringing down our operational carbon. We've been updating our building code every couple of years to have more stringent requirements. Industry has been find ways to do more with less in terms of much more efficient energy systems. We've decarbonized our energy systems as well, right? Solar panels, wind turbines, getting rid of coal. When you add all of that together, we've really shrunk that operational carbon significantly, but we haven't really done a good job of reducing the embodied carbon. So the relative importance of these things has changed hugely over time, and embodied carbon has become much more relatively important because it's a bigger piece of the remaining carbon pie, if you will. Things really get interesting if we think about shorter timelines in this this lower operational carbon scenario, right? If you look at the blue box at the start of the lower left-hand corner, operational carbon, it all happens up front when we build the building, basically, or the majority of it happens there. So when we take that into account, we see now in some of these low carbon jurisdictions, when we have a highly efficient building, it really looks like that little blue piece of the box where operational carbon is minuscule compared to the carbon footprint that we're taking to build these new efficient buildings. And that's why this really has become something that is being urgently addressed in certain leading jurisdictions and by some organizations. So this is just another way to show the annual emissions of a building. So the ones we showed before, that was cumulative, right? That was when we add everything up and we're looking at what's in the atmosphere in any given year. This is just the instantaneous annual emissions from a building. And you can see here again that the embodied in the pink happens mostly up front. And then we have another few pulses of it throughout the life of a building where we have a major replacement or refurbishment or renovation of the building. And then we have some at the end of life for the decommissioning. This is an image actually from a study they did in California to show the last image I showed, that was kind of just to show demonstrating the concept, but this is some real data that they modeled for California in terms of how much emissions are required to build their buildings. The ECI is the embodied carbon, the orange where it says ECI is embodied carbon intensity, and the blue, the OCI, that's the operational carbon intensity. So this is about comparing the amount of emissions that it takes to build in this example is California versus operate. And you can see that the annual operational emissions goes down over time because we're decarbonizing the grid, right? This is all about new buildings that are going to be using less and less carbon intensive energy over time. And because of that, as you can see into the future, when we start hitting 2040, 20 and beyond, we have extremely low operational carbon, but the orange from the buildings are still massive. And the cumulative on the right-hand side, you can see here, even out to 2084, when taking into account the future operations, assuming again that decarbonization trajectory for operations, you can see that even when we look at 50 years into the future, embodied still dominates in some of these regions. Put another way, this is another way to kind of show the same thing. We have our carbon pie, and it's getting smaller and smaller because we're reducing operating carbon, the gray, but we in the not too distant future, embodied is going to be pretty much the whole pie, and we need to start managing that. This is another example of kind of similar thing, but this is from the Canadian context. This was a primer that the Canada Green Building Council put out a few years ago, and they basically were looking at the relative split of embodied carbon versus operational carbon in different regions of the country. And you can see on the right-hand side, those graphs, there's three different locations. The top one is Vancouver, the middle one is Toronto, and the bottom one is Calgary. And in this study, they basically said, what if we're building, buildings of the future, fossil fuel free, what they modeled here was using I think it was geothermal air source heat pumps. It's all electrically heated buildings. And when they compared the embodied emissions associated with that in the three different regions versus the embodied, this is what they came up with. So you can see on the top, it's very hard to even see the operational piece. There's some bars that are going just across the bottom that rise up there. And in Toronto, it's higher. This is because Toronto has a higher carbon intensity in our electricity, right? If we're using only electricity, it has a higher carbon footprint than it does in BC. And this really goes to the extreme in Calgary, where the gray shoots way off the scale, and they actually had to shrink the axis of the green axis there. The green bars in all three of those are the same. It's all just over 20,000, but they had to shrink the axis in the Calgary because the gray went so far off the scale. So this is just to show, some regions in Canada, depending on how we make our energy in those regions, might have a higher proportion of embodied versus operational. So this is that, we shouldn't be viewing building design as a one size fits all. We need to be thinking about those conditions, both the climate and the energy system. So in some areas, it might make sense to focus on one over the other. And my big takeaway in this is that in BC, in Ontario, in other places that have low carbon grids, embodied carbon is the vast majority of the emissions for new high efficient buildings, and we need to really be managing it. So good segue into management opportunities. How do we actually reduce the embodied carbon now that we know what it is? Well, the first thing is actually just use less stuff, right? It's not rocket science, but it's not something we're doing a very good job of. We over-design almost everything that we build these days. And a lot of these materials traditionally haven't been that expensive, and it has been, people just add extra material on to make sure, as a safety factor, but we've got safety factors on top of safety factors on top of safety factors. So I'm obviously not proposing, we don't want to build obviously unsafely, but we can still do we can do the same amount of service for a significant reduction in materials if we are smart about how we do that. And this image just shows that very, very plainly. You can have the same slab thickness of concrete, you can have the same strength, but if we create it off-site in a precast manufacturing facility where we can optimize the shape and the manufacturing process, we can get something like the example on the left, and you can see it has probably 30 or 40% less material than the one on the right, which is a poured slab on grade or cast in place. The other but real big good news with this is less materials typically means less cost as well. So we've seen some examples of projects that when they really prioritize this, to really think about how we can design smartly to use less materials. There might be a little bit more money in the design, but it often is more than paid up for in less material purchases. So that's the first thing to really focus on, is making sure that we're looking for material minimization strategies. Once we've kind of minimized our materials, then we want to make sure that we're buying low carbon materials. And again, the good news is that there's lots of examples of low carbon materials across the country, and they have zero to small to no cost premiums, which is often surprising for people. A lot of people assume if I'm going to have a lower carbon material, it's going to cost more money, and that can be the case in some cases, but it's not. It's not a hard and fast rule. I often describe this as, this is a metric that we haven't been optimizing for. No one has been asking what the carbon footprint of your bricks are or your steel is. And once you start asking that, you can uncover a lot of low-hanging fruit. Um, we've seen time and time again, we can get up to 10 to 30% reduction in our embodied carbon for basically no cost premium. It's just about asking, comparing, and then making the lower carbon decision. Because there are very different ways to make these materials. If one of them is made in, one location versus the other, if you're using hydropower from Quebec to power your factory versus something in Alabama or Texas that's using coal to power their factories, that has a massive change in the carbon footprint of the materials, and it doesn't always translate to a dollar differential in the purchase price. So again, it's really just about asking and looking into what the carbon footprint of your materials are. There's this recent study. I'll share the slides after the presentation, but there's some live links in here, and this is a really great study by Clean Energy Canada that just shows these metrics that I'm referencing, that there's significant savings for basically a rounding error in terms of cost. And then once we are comparing materials, the thing that we would really want to look for and ask for is something called an environmental product declaration, or an EPD. And this is just an example of using industry average environmental product declaration on the left for ready mixed concrete, and then a proposed manufacturer's actual material EPD on the right. So on the right, we have a EPD for an actual concrete mix from Lafarge, a large concrete manufacturer, and we want to pull out the carbon footprint value on this and compare it against the industry average baseline on the left. So these documents, they're not super, sometimes they can be not super user friendly. So I kind of just showing you here the key things to look for. You would want to make sure that in this case, this is concrete. So we want to make sure that the strength that we're looking at is the same, because you can have different strength classes of concrete. So we're looking at 25 MPa. That's the strength. So we want to make sure that both EPDs are the same strength. You can see the purple box on both of them. It highlights 25 MPa. And then the metric that we want to compare is the GWP. So that stands for global warming potential. And that's just another way of saying the carbon footprint. So you can see on the industry average, if you look under the GWP, it says 254. And if you look on the proposed GWP here, it doesn't even say GWP, it says climate change. So again, this is not always super one for one, but climate change is the same as GWP, though it's both the carbon footprint. You can see the units are the same actually, right? Kilograms of CO2 there and kilograms of CO2 there. And the number is 130 there, right? So then at the bottom here, we just said 130 versus 254. That's 48% below the baseline. So this, if we buy this Lafarge mix, we're actually you can say this concrete is 48% below the industry average carbon footprint for concrete of a similar strength class. And then another thing that we're seeing a lot of excitement about actually in the last year or so, I'd say there's a big movement around this lately, is circular construction, how to reuse materials, right? Instead of having a one-time lifespan for some of these materials that are perfectly good after the building might be decommissioned, how can we integrate that into the next design and reuse it instead of sending it to the landfill or even for recycling, right? Reusing a material as is a much lower carbon impact and less waste and less transportation. There's many benefits to reusing materials as is instead of even setting them for recycling. We have a picture of the Parliament building on here just because this is one of the showcase projects that's happening right now in Canada for material circularity. They are actually taking down structural steel from within the building, like members like on the left there. They're taking them out, they're cleaning them up, they're testing them to make sure that the strength is still there, and then they're actually using the same steel and putting it back into the building. So this is demonstrating that really, this is possible. And then on the right, brick is a prime example of a material that we can reuse. In the past, it's been difficult to reuse it because the mortar around the bricks actually kind of gets stuck to the brick, and it was a very manual process in the past to chip it away, and sometimes the bricks would break, and it wasn't worth the time and effort to clean the mortar off it. But there's actually some new technologies and there's a machine called brick recyc or recyc, but it's in French, so they pronounce it brick recyc, but it's from Quebec, and it's an incredible machine. I've been to a demonstration, and it basically has some saws. You put the brick in the middle, it slices right along where the mortar joints are, it scrapes the edges off, and you just have basically get one through the construction site, and as the bricks are coming down, you just have someone feeding the bricks through the machine. At the end of the day, you've got a whole slab of or a whole sheet like this full of bricks that looks brand new. So there's new technologies, there's new material, there's new approaches, and I would really recommend anyone that's looking into this. I'd be happy to share some links, but steel reuse, brick reuse, we should be doing that on all of our projects going forward. And municipalities, one thing that you can do is actually setting a target amount of salvage materials on your project. Start small, right? Say it's 1%. Maybe say if our new city hall, we're going to have 1% salvage material, and then we can source the brick for one of the back alleyway or something from somewhere else. Like there are ways we can do this to start incentivizing this in the market without having to do the whole building in a new way right off the bat. But we need to start somewhere. So I would recommend people to start thinking about setting some kind of these small recommendations and building up over time. And then finally, low carbon construction in terms of the construction process. This is something that we haven't seen a lot of action on in Canada yet, but there's examples in Europe where some municipalities have set mandates that their construction sites have to be zero carbon. And it's great. I mean, it's good for the climate, but it's even better for the local communities because we don't have particulate matter being emitted, right? We don't have diesel trucks. It's just crazy to me that we are we can be building in zero carbon in locations that have zero carbon footprint electricity grids like Quebec and BC and Manitoba. But instead of plugging into the grid or using batteries, we're burning diesel, right? We need to do things different. We need to get our construction equipment to make use of our low carbon electricity, and we need to decarbonize our fuels where that's not possible. And there are options on the table. There's renewable diesel. You can see this in this graph that if we go, we can blend our diesel, and as we blend a higher amount of biodiesel, our carbon footprint comes down, and then we have renewable diesel, which is very low. And this equipment does exist. It didn't exist in Canada a few years ago, but I've heard some people say, "Oh, it's not available on the market," but that's just not true anymore. I took this photo of an electric equipment from Cooper, is the rental organization that rents out construction equipment to large manufacturers. This was a multiplex construction site in Toronto, home of the future Etobicoke Community Center. So these technologies do exist, but we need to have municipalities and others speak for them and mandating them and saying, this is what we expect of our projects going forward. So I'll talk briefly about some of the standards and policies. For anyone that's not familiar, the Toronto Green Standard has been in place for over a decade in Toronto, and it sets minimum sustainability requirements in order to get a a site plan approval. And it has this tiered approach where tier 1 is required to get your site plan approval. And then tier 2 and higher are voluntary higher levels of ambition from sustainability. And if you decide to get those higher voluntary levels, you would get a financial incentive associated with them. And then the really innovative thing is every few years, the tiers shift kind of. So the tier 1 becomes retired, and the things that were tier 2, right, that were previously voluntary, those now become mandatory. So in this way, it's kind of showing the roadmap to the industry about what the future decarbonization requirements look like, what's going to be required in a few years. And it's been a very effective policy. So in 2023 or 2022 or 2023, around then they updated it to version 4, and there were some really innovative changes. Oh yeah, it's 2022. It's on the cover page right there. But they had some really useful and innovative approaches around waste and the circular economy to make sure that materials are getting reused where possible. But we really, but we they decided that they could go further on embodied carbon. So we actually, my firm Mantle worked with the city planning department to do a significant study where we basically did the first benchmarking of embodied carbon for large buildings in Ontario, and we basically looked at, we asked the industry and we said, if you've done an embodied carbon assessment, share your data with us. We want to just understand, where these numbers are falling in the range, what might be a reasonable number to start mandating going forward. And we came up with the graph on the top there, where we looked at different building types. We split them into residential versus commercial versus others, so community centers and things like that. And we could see that the numbers were, there was a range, but the medians were all around that 400, like high 300s, low 400 number. And that gave some consistency or it made the city realize that there was some consistency in these numbers. There was a number that they might be able to set to regulate and say, we want people to aim to be below that number. So the other thing that really helped that this helped the city was that they realized that people were doing this already, right? They didn't think anyone was going to have data to share with us because they said, well, there's no requirement for this. And we realized, people are doing this voluntarily because it's A, the right thing to do, but B, they're doing it for their LEED certification, they're doing it for their zero carbon certification. So there's a whole host of developers out there that are already familiar with low carbon approaches, even though it's not being required by the city. So this helped the city understand that asking this more broadly would not be, throwing a totally new thing into the industry. It's something that a big chunk of the industry was already doing. And then we did another really interesting thing where we did a pilot project with the city, where the city said, we have this project. It's a new emergency medical services ambulance headquarters, and the design was already complete. And the design, it was being designed to be zero operational carbon. Actually, back to Nathan's intro, they had all the roof is full of solar panels, and they were super efficient on the operational side, but they hadn't really looked at the embodied side at all. They hadn't looked at the carbon footprint of the materials and how to minimize that. So we came in and basically said, let us take a look at the design. Let us look at where it might make sense to make cost neutral material for material swaps and reduce the carbon footprint. It was really interesting because the architects were not thrilled about being told that an engineer was going to come in and look at all their designs and give them all these recommendations, because they said the design is done. We're not changing things. We don't want you to tell us to revise everything. And we said, hey, we're not gonna tell you to redo the whole building. We're gonna see where it makes sense for a simple, low effort swap of material A to material B, and we'll see where the numbers land. The results blew everyone away. The architects couldn't believe it. This image, this waterfall graph you can see here, we found a few, there's 6 things on this list, 6 solutions. Just the 3 big ones there was a 26% reduction in embodied carbon by doing things like asking for lower carbon concrete, right? We're not everywhere you had concrete, we're still going to have concrete. It's just going to be made in a different way with different ingredients, and maybe a 2% cost premium. And there was a huge reduction in the carbon footprint. Look at your insulation. Instead of using standard XPS blown insulation, let's use a slightly different type of insulation that has a lower carbon footprint. And then the one that surprised everyone was just the sealant that they had to put on the slab on grade, because it's a big parking lot, basically. Like, the interior area is where they park all the ambulances, and they had to use a lot of concrete sealant, and it had a really high carbon footprint. It was very volatile and had a high global warming potential. So we were able to find a lower carbon impact chemical that did the same thing, but it was just a lower carbon version of that. So at the end of the day, the architects were like, I would never know that you made these changes. It didn't cost us anything else. It's just we needed someone to look at the carbon footprints and find a similar product that had a lower carbon footprint, and it was a 26% savings in embodied carbon. So again, it falls right into what I said before of 10 to 30% savings you can have for zero carbon or zero cost impacts rather. And then this policy, we did a primer report on our website. Again, it's on our website. I'm happy to share the direct link with anyone if you want to reach out to me afterwards. But we've got a number of strategies and recommendations for materials for concrete, steel, wood, insulation, and then also on the design side of things. So things to think about like eliminate underground parking, or reducing transfer structures between levels. So lots of good recommendations in there. And then we set the new policy based on all the findings. So we have this 350 kilograms of CO2 per meter squared, or 400 for non-residential buildings. So this is the Toronto Green Standard voluntary tier 2. Again, this voluntary level of performance, where we actually have a metric that people need to be below. Again, that is voluntary. The tier 1 doesn't have anything, so we're not saying every building in Toronto, every large building has to do this, but the people that do want to be leaders, they can now follow the tier 2 path. And the idea is that tier 2, again, will become a tier 1 in the future and required in the future. I want to leave some time for discussions. We're going to try to go through these last slides kind of quick, a little bit quicker, but we did a phase 2 follow-up report with the city as well to look at additional topics on how we can reduce embodied carbon through other approaches, not just the building approvals, but we looked at urban design, procurement of low carbon materials when they're buying materials to make infrastructure like roads and sewers, and circularity. So again, the links in here are all active, and this is on our website. This is an example of some of the recommendations that came out of the urban design part of the work, where we looked at the carbon footprint of different parts of a building. So underground parking is very large, has a large carbon footprint because of all the retaining walls. So recommendation was to minimize underground construction. The ground floor, often when you had a transition between parking and residential, that's where we have all kinds of weird structural gymnastics happening to line up the columns, because there were different column spaces between parking stalls and residential units. And we wanted to try to minimize that. So just simply not having underground parking and making sure your columns are aligned, we found had a massive reduction in carbon footprint. And again, that's not, there's no cost associated with that. It's just better design, understanding what to avoid. Similarly, they looked at step backs on, we've had a push towards having step backs like at the top of the slide to reduce shadows, but that actually to reduce shadows on the street and have more sunlight directly on sidewalks, but that leads to much more structural gymnastics, again, to transfer loads, and it leads to less habitable area, right? So some of these things have unintended consequences that we didn't really realize when we put these policies out there. And we just showed that as the step backs get reduced, the embodied carbon gets significantly reduced as well. Circularity, we have recommendations around adaptive reuse of buildings, having waste audits, potentially tying material deconstruction requirements or building deconstruction requirements or reuse requirements to a demolition approval, so that if you're going to demolish, you have to at least salvage some of the material and have a reuse strategy for them. And then we made some recommendations around just procurement of low carbon materials. So the main recommendation there is to align with the federal standard on embodied carbon in construction, which I will talk about right now. So this one, it's called part of the greening government strategy. It's basically the federal government's requirements on low carbon materials. They have a few different kind of sub policies. One of them is on on disclosure from their large suppliers. But the one that I wanted to focus on is called here, it's Appendix A, Standard on Embodied Carbon in Construction. And this is all about requiring low carbon materials. It's right now, it's limited to steel and concrete. And it does apply. It launched in 2017. I think they launched in 2017. It became active in 2019, and it was just updated in 2015 to include additional materials like steel. It was originally just on concrete, but then they added steel last year. And it is applicable to all Crown corporations. So Canada Post, Via Rail, CBC, LCBO, Bank of Canada, all of those organizations are supposed to be following this requirement and ensuring that they're using low carbon materials. They also have a requirement in here that they have a target of 30%, or a requirement that their buildings must be 30% lower carbon than a baseline building or an average construction building. So again, we're we're looking to use lower carbon concrete, lower carbon steel, minimize materials, avoid underground construction. When you add all those strategies together, you should be able to get to 30% reduction with little to no cost premium. And actually, I don't think I have a slide here, but the policy does also say that a 2% cost premium is where you can stop. So basically, they say do initiatives until you get to a 30% reduction in carbon, or you have a 2% cost premium, whatever comes first. So the project shouldn't have to pay more than the 2% premium to hit these targets. In terms of the specifics on the materials, they basically, again, say ready-mix concrete and structural steel need to be 10% lower than industry averages. So there's published values in the standard where you can put into future specifications on construction projects and say you have to be below this certain threshold so that we can hit this standard. So that was a bit of a whirlwind. I know that was a ton of information, but wanted to share that with you, and hopefully there was some interesting and new learnings in there. But yeah, happy to answer any questions or have a discussion for the rest of the time that we've got together.
Yeah, thanks a lot, Ryan. Really great presentation and hit on a lot of good points that I think some people are wondering about, how to kind of think more about embodied carbon in some of their projects. And I'd love to open it up to questions or get into more of a discussion. Feel free to put your questions in the chat, unmute and ask a question directly. Or you can private message me if you don't want to be identified. Anything like that. Yeah, I'd love if anyone, has been working on some embodied carbon or thinking about that in some of their projects to kind of share some of your stories as well. Yeah, Dan.
Hi, Ryan. How you doing?
Good to see you.
Great presentation, as always. Fantastic stuff. One thing that I've been trying to do so I'm Dan Skag, I'm from Ottawa Community Housing, and we're doing some large redevelopment projects right now. And embodied carbon has not historically been kind of something that we asked of our architects. I've started trying to just include it, not from a certification point of view, but mostly because I want people to start asking the questions, right? Literally, as you pointed out, sometimes it's so simple, you just didn't think about it. The way that I've been approaching it is I've been the dart that I've thrown is I've said, hey, I want you to give me this, even though we're not going to get certified, I want you to give me the same embodied carbon inventory that we would do for the zero carbon standard from the CAGBC, so that I can point them to at least some structure. And then I've been using the Build It for Climate Change target of under 250 kilograms per square meter. Those are kind of the two darts that I've thrown. I would love to know your thoughts on if there is a better place to start when trying to get people who have not done these things before, just to kind of wade them into start doing some inventory, start doing some embodied carbon analysis, so that we can literally just get the conversation going and find out some of these easy low-hanging fruit.
Yeah, thanks, Dan. So just so folks know, the 250 number that Dan was referring to, that's a number that the group put out called Builders for Climate Action. And it's actually part of I didn't have enough time to go into all the details, but that's part of the low-rise Toronto Green Standard as well. So there's different versions the one I was showing was for large construction or Part 3 buildings. There's a smaller construction version that references the number that Dan said, the 250 number. So that's why the numbers are a little bit different. But yeah, there's a tool that they've released as well called the BEAM tool, BEAM. And it is a really good user-friendly way for people to estimate the carbon footprint of their building or of their different, components within the building. That can be a lot to chew off, though, for people who have never done this before. I'd say to keep things really simple, start with one or two materials, right? And those are always, I say, it's concrete and then steel, right? Say, what's the carbon footprint of your concrete and steel, and can we find a lower carbon version for a cost premium amount? We do have, and I guess the way to help them, where you want to look for to get that information is through an environmental product declaration or an EPD. So the first thing I would say is to request that they submit EPDs for their concrete and steel. That would probably be the first thing. And then once they have that, it's about, okay, have you compared the global warming potential value, the GWP, that's within the EPD? Have you compared that to the competitor? Because you might find that option, the second material option you're looking at, it might be again, right, 1% cost premium, but it might be half the carbon footprint. Right. So just starting to get more literacy around these things and having carbon be a metric that we optimize for, like we do costs, like we do, any other metric, right? Wherever I see cost, I want to add carbon. We need to be making decisions with both of those metrics in mind. It's not just low cost at all cost. It's finding the sweet spot of a cost and a carbon that both make sense.
Sorry, if I can follow up. So if I told them, hey, just don't worry about doing all of the tiles, all of the windows, all of that. If we focus just on the steel and the concrete that we're going to have in our buildings, is it the answer is like, hey, you're probably going to touch on 80% of your embodied carbon anyways. Like, do you know what kind of a
Yeah.
slice we'd be targeting?
Well, for large commercial scale buildings or
Yeah,
partner buildings,
20-story
community
building.
centers, those are like typically it's 50% of the carbon footprint is concrete and another like 30% is steel. So yeah,
Okay.
when we do these assessments, it's the 80-20 rule, 80% of your impacts are from 20% of the materials. It's concrete, steel. If we want to add another one, insulation, right? That's where the carbon footprint is. So, and underground construction, as I said, right? That some of these are material specific, some of them are design specific. So I think combining those, you will have a very low carbon building. If you have no underground construction and you are using lower carbon versions of your concrete and steel, you're going to be golden.
Yeah, perfect. Thank you very much.
Yeah. I see a
Uh,
hand there from
yeah,
Leah.
Leah.
Hi, Léa Mété from the city of Quebec.
Uh,
One of your first slides, you show a horizon of 60 years for to project the greenhouse gas emissions, and I was wondering how realistic that 60-year window for a lifetime use of a building is, and if so, shouldn't that be a huge part of the conversation? Because again, I don't see many buildings from the 60s being demolished, and I cannot fathom that we're actually building for 60 years.
Mm. Yeah, it's a great thing to point out. That comes from LEED, actually, the LEED Green Building System that they use 60 years as just as the what they call it, study reference period, just the amount of time that the studies typically use. But it's a great point. We should be building for longer than that, obviously. And yeah, we need to. I like to just think about upfront carbon emissions. Actually, I don't even think about the 6 years because we have such an immediate climate impact that I think we need to be worried about the next 5 years, the next 10 years, right? Not 60 and 80 years. But your point is well taken. We should definitely be building we should be building our building to last as long as we can. And again, when buildings can't go on in their current form, we should be having thoughtful deconstruction of the materials and thinking about how we can reduce them.
Sweet, thanks. Because I'm a big, partisan of reuse and refurbishing and stuff like that. And I think it skews our conception of what a building should look like in the future if we consider, for me, a 6-year-old horizon is like disposable. And that's so wrong.
There's a really good standard actually. The CSA group has a standard on design for disassembly. So it's if we design in a way that we can disassemble the building and disassemble the components. So using minimizing the use of adhesives because it's really hard to unadhere things, but you can take a bolt off and take pieces apart, right? So there are design approaches that can help with the disassembly, and that's something that I think we need to be focusing on more as an industry as well.
Thank you.
Any other questions or comments or stories to share about people's trying to implement some of these things?
Hi there. My name is Ruth. I'm from the city of Richmond Hill and just north of Toronto. And as you may know, that there's a lot of changes with the provincial government in regards to how we are now permitted to implement our green building standards. We have the sustainability metrics here with our neighboring municipalities, Vaughan, Markham, and Brampton. So now, with all the changes, do you have any updates working with staff at all in Toronto in terms of what to do in regards? Because it doesn't look like our ability to mandate these above code metrics are implementable anymore. We're being challenged. So this
Yeah.
is I'd like to ask. Yeah.
Yeah, that's a very tricky topic. And so the province, just for anyone that's not so familiar with this discussion, the Ontario province of Ontario has said that as a way to streamline construction and try to reduce costs and try to speed things up, they're basically saying that municipalities cannot require any green development standards or anything that is higher than the Ontario Building Code. We could go down a rabbit hole as to whether that's a true statement or not. I mean, I think that they're using that as a scapegoat. Construction is expensive everywhere, not just in places that have green development standards, right? I think they're trying to use it as an easy victim or an easy excuse as to why construction is expensive. But they haven't said that you can not have any more green development standards. It's just can no longer be a mandatory requirement for part of the approvals process. So I think my understanding is that municipalities are moving towards just having them as the incentive part, so that if you were to do these green standards, then you would get some kind of a benefit, right? So it could be more density, or it could be a streamlined, faster approvals process. So I think these requirements will still exist. They're going to move out of the required box, and they're going to move into the incentivized or incentive box. What we really want to see as an industry is consistent green development standards across the board. And how that would happen is if it was in the Ontario Building Code, right? The reason municipalities have done this is because the Ontario Building Code is silent on sustainability. There's been a vacuum of leadership, and no one has told us in the province what a green building looks like. So all the cities have made up their own approaches, because we need guidance on that. It's an extremely important topic. But what that led to was a patchwork of regulations where every municipality, well, you guys did it the right way, actually. You combined with your neighboring municipalities, right? But there was at least a dozen different green development standards across Ontario. And that's obviously not good for developers, right? We don't want to have, if you cross a street, you're going to have a different set of rules you have to abide by. But I think the solution to that is having the Ontario Building Code give us guidance on what sustainable buildings look like. And I was actually at an event a few weeks ago that the Ontario Minister of Housing and Municipal Affairs was speaking at, and he did say that is something that they're looking at, to have some kind of a tiered green development standard in the Ontario Building Code, and then it could be up to the individual municipalities to choose which tier they want, right? So there's some consistency in that it's the same playbook across the province, but then depending on where in the province you're located and how much, how the industry is, how far the industry wants to go, or how far that part of the province wants to go in terms of sustainability, they can choose their different tier. So that's what I'd like to see. And I think we just need to, I think their argument that green development standards is leading to more expensive construction, I mean, I think it's totally backwards, because we don't want to build things that are cheap, that, again, at Talia's point, that you need to replace in a few years, right? We want to build correctly for the long term. And green development standards helps with that, right? Green development standards means we're putting on green roofs and reducing our flood risk. It means we're roughing in extra space for electric vehicle chargers, right? When we don't do those things up front, we're going to have to renovate the building in 20 years. It's going to cost 10 times more to add them, right? So this is about long-term value. And I think we need to be clear and tell our provincial representatives that, we expect our building codes to help us with long-term value of our assets, not just a short and cheap construction.
Thank you.
Jillian.
Hey, Ryan. Sorry, I'm just getting my video here. Sorry, I'm on my couch. Great presentation. Thank you so much. Just based on what you said and what Leia mentioned as well. Sorry, I hope I said your name right there. How do we as we explore newer materials, I think I saw hempcrete mentioned on one of the slides there, how do we weigh potential sustainability, carbon benefits against risks like moisture, mold, shorter service life, that kind of stuff, especially when we're trying to build the durability and resilience over decades and decades, right?
Mm-hmm. Yeah, that's a great point. I would say pilot projects, right? Start small. Also look for applications that might have lower risk, things that might be easier to replace, or, one example is when I've heard quite, or, seen quite a few case studies where people were not familiar with low carbon concrete. So, you're not going to start by building a hospital of it, right? You're going to start with a sidewalk. Right, something that has a low risk tolerance, or if things go bad, it's not gonna, it's gonna have a less of an impact. So I think it's about finding the solutions when you have something that is maybe it's temporary structure, or maybe it's something that it's just going to be used a few times, or it would depend on the situation, obviously, but just trying to pair the use with the material and look for opportunities to pilot things. That would be my advice. Yeah.
Great. Thank you so much. It definitely raises the question, like how do we do this to scale? But I appreciate it. Thank you.
Yeah. Thanks. Kat.
Hi, thanks so much. I work on a research project around building climate solutions in rural and remote communities. I'm out here in BC, and I'm kind of just wondering what your perspective is on I guess accessibility and cost in rural areas with some of these different materials because they might be manufactured in one place and then have to be shipped, and then the cost is like
Mm-hmm.
exponentially higher. So
Mm-hmm.
I'm just curious what your thoughts are on that.
Yeah, yeah, another great point. So we want to look at the A4 as well. That's the transportation impacts. So EPDs is A1. Sorry, I was trying to pull up the slide, but it's going to take too long. Just describe it. The A1 to A3 is the EPD. That's what's typically shown on an EPD, and that's the manufacturing process itself. But then the A4 is the transportation to the location, right? So that can have a big impact. So we would typically look at when we're comparing materials, we wouldn't just be using the EPD number. We would also add on the E4 to say what is the transportation impacts as well. And the federal, again, I didn't have time to get into all the details, but the federal standard on embodied carbon in construction, it actually has it says that in the territories that you don't have to actually meet the requirements. So some of these policies do have remote location considerations built into them. Or I think actually one of the other things that they did is if it's like a super cold climate application, then you can like increase your baseline by 30%. So sometimes there's some kind of ways to consider that, but yeah, it's a great point that we need to think about where we're locating these projects. Something I would say is using more local knowledge in our designs, using more wood-based construction. You might, if you're in a rural location, you don't want to order some super innovative material from Europe, right? You want to use local approaches, which are often lower carbon at the end of the day, right? So looking back to traditional knowledge and indigenous knowledge and ways of doing and the architecture that they've used in the past, use that as your inspiration, and you can often find lower cost local solutions.
Hi, everyone. Just wanted
If
to
that's
jump in
helpful.
there. Yeah, thanks a lot for the answer, Ryan. And yeah, I still see a couple of questions coming in, but we're gonna have to call it at 3. So I'll get back to anyone and can send those questions to Ryan if we need. But really appreciate the discussion and great questions today. The presentation was awesome, Ryan. And I think, yeah, I want to continue this type of conversation with good people and making sure we, think about all the aspects of building to net zero. So join us again in February, and yeah, have a great rest of your week, everyone.
Thanks, everyone. Feel free to reach out to me if you wanted to continue the conversation or if there's anything I can help you out with. Okay, take care. Bye
Goodbye.
bye.